Alright, we're going to go ahead and do difference of squares. This is Algebra 2, Semester 1, Unit 3, 3.3. Bridge Math Semester 1, Unit 4, 4.3. The section will be called Special Cases. So the formula for difference of squares is a squared minus b squared equals a plus b, a minus b. What we need to understand is that we will see a squared, but what we're going to be focusing on is a. So what we might see is we might know that a equals x, or maybe a will be 2x, or possibly a is even like a 10x squared. So these could be all the a values that we'll be working with. However, what we'll see in the equations at the beginning, well, a squared would be x squared, so we'll see an x squared. For this one, it would be a 4x squared. Down here, this would be 100x to the fourth. We could even have an a is equal to two variables, an x, y. So this would tell me that a squared equals x squared, y squared. So what we'll see is going to be different than what we're going to utilize when we solve the problems. You can see the first 10 perfect squares. I would have those written down. I'd probably actually expand into the first 15 or first 20. Just have it on a piece of paper just so you can refer to it easily and quickly. Hey, these numbers are perfect squares. They mean something to me. I kind of identify them when I see them. Let's just jump right into solving a problem. So we're given x squared minus 9. What we want to solve for is a. Well, what we need to know from the formula is that a squared is everything in front of the minus sign. So a squared is everything in front of the minus sign. Well, everything in front of the minus sign here is x squared. So we have a squared equals x squared. Well, we need to solve this. We need to solve for a. Well, a has a squared with it. How do you get rid of a squared? Well, I square root. And what I do to one side, I must do to the other. Square root of a squared is a. Square root of x squared is x. So a equals x. And then what we need to do is, well, b is everything that's after the minus sign. Well, what's after the minus sign? Well, that's a 9. So I know that b squared equals 9. Same idea, I need to solve for b. What's with b? There's a squared. How to get rid of a squared? I square root. And what I do to one side, I must do to the other. So square root of b squared is b. The square root of 9 is 3. And what I end up having here is I have a equals x and b equals 3. Well, if I go back up to my formula, I have a plus b, a minus b. That's my formula. Well, I have an a and a b now. So it's an x plus 3 and an x minus 3. Boom, I am done. That is solved. That is done with this problem. That's all they're going to want. Going over to this one, I know a, same idea, is before the minus sign. So a squared equals x squared. I square root both sides. A equals x. I'll do the same thing for b. B squared equals 81. Square root both sides. B is equal to 9. And then I have an a and a b. I use my formula, a plus 9, a minus 9. Now that problem is solved. The next one, we have 4x squared minus 16. So this will be the first one. It's a little bit different. Still the same rules. What's before the minus sign is my a squared. So my a squared is going to be 4x squared. I again have to take the square root of it. So I take the square root of the first piece, square root of the second piece. So a is going to equal, the square root of 4 is 2. The square root of x squared is x. So a equals 2x. I'm going to take 16, which is my b squared. And I'm going to go ahead and square root that. b equals 4. So I have an a and a b. I can plug right into the formula. It's 2x plus 4 and 2x minus 4. Boom. Moving on, going quick, but it's kind of a simple process, right? So now, We have x squared y squared minus z squared. Well, before the minus sign is my a. So a squared equals x squared y squared. Same process. I have to square root. What's the square root of a squared? Well, of course, a. So a equals x, y. The square root of x squared is x. The square root of y squared is y. So a equals xy. I take my b squared, which in this case is z to the sixth. I square root both sides. Well, the square root of z to the sixth is z cubed. How? Well, z cubed times z cubed equals z to the sixth because you add the exponents. So anytime you multiply the same base, they're both z's, two exponents, I go ahead and just add them. And then I have an a and a b. I can go ahead and down here on the bottom, it's xy plus z cubed, xy minus z cubed. Straightforward, simple. Now next one, all right, cool. Looks more complicated. Uh-oh. What's the problem? Shouldn't be a problem, right? We're going to solve it the exact same way. So now I'm not even going to set it up. I'm going to take the square root of the first piece. I know a is equal to, well, the square root of 25 is 5. Square root of x squared is x. The square root of y to the sixth, y cubed. We're going to take b. b is equal to, well, the square root of 64z, and that's actually supposed to be to the fourth. I just didn't finish writing it, my bad. So the square root of 64 is 8. The square root of z to the fourth is z squared. And then I'm just going to add these together and subtract them together. So even this one, which was kind of ugly and kind of complicated, it's still the same idea. I take the square root of the first piece in front of the minus sign, and I take the square root of the second piece. I have my a and my b, and I can identify it. Now, so if I have another example, say I put 20x squared minus 16. Am I able to do this? Well, what's the square root of 20x squared? Well, 20 is not a perfect square, so therefore I cannot solve this problem using difference of squares. Can't use this one. Ooh, where'd I go? How'd that happen? So because this one does not have a perfect square in the front, 20, because not every piece is a perfect square, I can't use it. I can't use this formula. I'm going to have to try a different method. So for it to be a difference of squares, the first term, however many things are there, the first term needs to be a perfect square. It needs to be able to take, you need to be able to take a square root of it evenly. There needs to be the final term needs to be a perfect square, right? We've been doing that. You have to be able to take the square root of it. There needs to only be two terms, and they must be separated by a minus sign. So you need two terms, both perfect squares, and separated by the minus sign. If you have that, you can do exactly what we just did.